So hello everyone, in this video we'll solve LeetCode number 1521, a hard level problem. Find the value of a mysterious function closest to target. We are given an array of integers and a target value. Our task is to find a subarray whose bitwise end gives us the result closest to target, and we have to return the minimum absolute difference. So let me explain it step by step. We are given an array and a number target. We need to find a subarray, say from index L to R, and compute the bitwise end of all result of all elements in the subarray, and calculate the absolute difference between this calculated end value and the target value, and return that minimum possible absolute difference. So in this given array example 1, we have given array 9, 12, 3, 7, 15 and the target value 5. So we have to calculate all the possible bitwise end in this array and compute its difference with target value, and whatever the minimum possible answer we get, we have to return that value. So let's say we take a subarray 12, 3, 7. When we do end, we get a value is equal to 0, and when we do take difference with target value, we get 5. We now suppose we try another subarray, that is 3 to 7. When we do end value, it give value 3, and when we take a difference, it gave value 2, which is better than before. So basically our goal is we have to find such subarrays and get the minimum difference. Now brute force, we try every possible subarrays and compute the end value and take a difference with target, but that takes of n square, because to creating all subarrays and then check with target value, it takes a lot of time of n square, which give a TLE for larger size of array. So we have to go for optimized code. So we see one thing, bitwise end is a monotonic decreasing function. Mean when we end operation, basically what it done, end operation, it turns our set bits to off. So basically when we go in further value, end result might be going smaller or remain same. Our end result gets smaller or remain same. So because of this, we don't consider all subarrays blindly. So what is the approach we use here? We use here a set. We use here a sliding set here. So means I mean to say, at every index we maintain a set of end values ending at that index value, and we have to calculate from previous set values plus with this current value, and calculated what are the minimum possible values or what are the minimum possible differences with this target value. Let's come to example here. Like see, I take a array 9, 12 and 3 and target value 5. We have to return the what are the minimum possible difference here. So when we talk about I is equal to 0 index, we take a difference 9 so its end value comes to 9, take difference with 5, give 4, so minimum value is equal to 4. At I is equal to 1 index equal to 1, possible subarray is when 12 alone, so 12 minus 5 gives value 7. When from previous subarray 9, we end with current element 12, it give value 8. See, it gave value 8 and take difference give 3, so this is better option, so minimum is equal to 3. Okay, at I equal to 3, we see all subarrays that end at 3, so 3 alone, it give minimum difference at 2. When we extend this to previous element, so 12 and 3, it give value 0, so give value difference as 5. And extending to previous, so 9, 12 and 3, so 9 and 12 we know and gives 8, and when it takes to 3, it gave 0, so difference is 5. So what is the best answer in this? So minimum is equal to 2, and even all the best possible minimum value among I is equal to 0, 1, 2. So we try all the subarray values possible in this given array and try calculating minimum difference with target 5, and that give our result minimum is equal to 2, and that is our answer. So basically what we see, basically what's the trick here, even though we have many subarrays, and so but we know one thing: the number of unique AND value is very limited here, because see, bits after 30 to 32 bits, most of the AND combinations are repeated. Means whenever you represent any value, you represent any number in a binary representation, what are the maximum possible bits here? 32, say. Let's say we start from a number who has most of its set bits, most of bits are set, means all of bits are 1. When we doing its AND value, its bits are going to off. So after 30, say after almost 30 or 25 to 30 steps, it tends to 0 value. So basically at per index value we have at most 32 values. So our total time is of n log of m, where m, basically m is equal to maximum value of that array value. So when we doing its AND operation, its set bits going to unset, and after some time, after a small 30 operations, so at most, in worst condition, after these small operations, its value goes to 0, and after that same repetitions starts going, so that doesn't affect our answer. So so that's our code here. We make a set here, like that is our previous set. Initiate our num size is equal num size, we define a value n. We initiate our answer is equal to int max, so we have to calculate all the minimum possible value and compare and reset our answer according to them. So we traverse from I is equal to 0 to n. At every index or every set of traversing, we make a current set. Here our current set. So we current at every step current dot insert num psi, means in this set we insert a new element, that is new element, means when we talk about index number 2, so this number alone is a subarray. So our current set, current dot insert num psi, and for from it is equal to previous, means from previous subarrays we insert all of its value and with this new current element. So basically all of its previous value, when we doing AND operation with this current, and this number alone can our answer, and we do compare with the target value minus initial value, and redefine this previous is equal to current. So basically at each step, we define a new set, and it takes value that this new coming element and all of the previous element ending with this new element, and compare our answer, and that way return our answer. So that's our code.